Hello, this is a video on how to calculate percent yield. Percent yield is a lot like percent error, except yield is always referring to the products, and it's each individual product. So percent yield is about one of the products in your reaction. Now, it's a percentage, and as you know in my class, a percentage is part over whole. In this case, the part is what is called the actual or experimental yield. In essence, you did a lab or you did something, and how much did you get? That's called the actual yield. The other part of the percentage is the bottom part, which is the whole. And the whole is called the theoretical or stoichiometric yield. It's what you should have gotten. And that fraction is you multiply it by 100%. Because, of course, in the fraction, the units are the same. Therefore, after you do the math of the fraction, there are no units. That's why you multiply by 100% to get the percent unit. So, for example, you can see you have already opened up to this page, and it's a discussion of the, what we were just talking about, percent yield. Here's our equation: actual yield over theoretical yield times 100%. So an example of this is you're going to make some cookies. And of course, the recipe usually has a certain number of cookies associated when you do that. So a lot of times there are a 2 dozen batch cookies. So you take, for example, like 2 eggs and 1 cup of flour and a bunch of other things, and you should produce 2 dozen cookies. So your theoretical or stoichiometric yield is 24 cookies. Then you actually do this, and you make the cookies, and you end up making 18 cookies. Well, that's your actual or experimental yield. So your percent yield would be 18 cookies over 24 cookies times 100%, which would give you 75%. So your yield for making cookies would be 75%. Now, that's not for cookies. That's pretty good, but for chemistry and making products, that's a low percent yield for a lot of things. And there are various reasons why you want that percent yield to be closer to 100%. But we can talk about that in a different video. Now, there are usually 2 different types of calculations or problems with respect to these kind of percent yield calculations. One is a very simple one I just talked about, where they give you the actual yield, they give you the theoretical yield, and they ask you what the percent yield is. So you plug it into this equation here, and you get your answer. So that's the simple one. The more common one requires you to actually determine the theoretical, or the other name is stoichiometric yield. And since the name is stoichiometric yield, you would realize the fact to do that, figure out that theoretical or stoichiometric yield, you need to do stoichiometry. So that's why if you click on here, this example of work, I'm going to show you an example of those types of calculations, the more complicated one. So you have you're making water from hydrogen gas and oxygen gas. You have a balanced chemical reaction, which you always must have. And it says, if I react 4.52 grams of hydrogen gas, and then the parentheses is basically saying I have enough oxygen lying around that the H2 is my limiting reactant. So I'm going to react that many grams of hydrogen gas. And what I find is when I do it, I experimentally determine that I have 31.8 grams of water. So I made 31.8 grams of water. So I actually made that in the experiment. So that is down here, here's my equation for percent yield. My actual or experimental yield is 31.8 grams of water. So now what I need to know is I need to know how much I should have made, or my theoretical yield, again sometimes called stoichiometric yield. Okay, so I will have to do stoichiometry. But if you look in these types of questions, there's only two numbers, and you already used one of them, this one here. So as you know, in stoichiometry, you have to have a starting point. So usually what happens is the other number is your starting point for stoichiometry. So therefore, you start off with 4.52 grams of hydrogen. You convert the grams of hydrogen to moles of hydrogen because you did your little mole mass calculation. And then you know for every 2 moles of H2, you're going to get 2 moles of H2O from your balanced chemical reaction, which you have, or you can make up, or they give it to you, however you got it. And then now you have moles of H2O, and you're looking for grams of H2O. Therefore, you show your little molar mass calculation, 18 grams of H2O and 1 mole H2O, and then you ended up with 40.68 grams of water. So that's your theoretical or stoichiometric yield, which of course goes on the bottom. And of course that is just a fraction, so you got to multiply it by 100% to get your percent yield, which is 78.17% or 78.2%. It's a percentage, so sometimes I just tell you how many significant figures instead of you having to go through the calculations. But in this case, I didn't, so you use the regular rules for significant figure. So that's the more common one where you have to do stoichiometry inside the percent yield calculation. Okay, I hope this helps out, and have a good day.